In this video, we're going to learn how to find congruent angles formed when a transversal cuts parallel lines. Notice that there are a couple of important concepts as we talked about in the previous unit. First of all, I have a pair of parallel lines, let's call them A and B. And then I have a transversal, and that's T. And now, if you recall from 3.3, the transversal would create 8 angles. And it's really important that you understand how to recognize these 8 angles, the pair of several pairs of corresponding angles, alternate interior angles, and alternate exterior angles, and same side interior angles. Again, every time we talk about alternating, we're talking about alternating, meaning switching around back and forth on different sides of the transversal. So that's really important, that concept. Also, I want to point out that sometimes the lines are given, I'm sorry, that doesn't look right. It's the other way around. I can give you a line that looks something like this. And in this case, make sure that you recognize that the transversal is the horizontal line and my parallel lines are there, A and B. And in this case, I suggest that you turn the paper around so that you look at the diagram in the more familiar way, which is the one on the right. And what I want to point out, for example, 1 and 2 would be corresponding angles, but that's not as easy for some reason. Visually, for some of us, it's not as easy to spot as the 1 and the 5 here and the 2 and the 6 on the right. Okay, so let's continue with this. Here is a postulate, corresponding angles postulate. It's really important that you remember this because in this unit we're going to have several of those. I don't want you to get confused. So the corresponding angles postulate says if two lines are cut, if two parallel lines are cut, two parallel lines are cut by a transversal, then the corresponding angles are congruent. So in other words, in this example, if J and K are parallel to each other, then angle 1 and angle 5 are corresponding angles and they are congruent. 2 and 6 are corresponding angles. 3 and 7 and 4 and 8, right? They are all 1 and 5, both are on top of their lines. One is above J, 5 is above K, and they're on the same side of the transverse. So, and same argument can be made with other pairs. So these are 4 pairs of corresponding angles. That's that postulate. Let's see how we use it. In example 1, we're asked to find the measure of angle, in this case, angle 6. And in this case, it's angle 5 and angle 2. And if you notice that angle 6 in A and that angle at 60 degrees are corresponding angles. Same thing here, 5 and 135 and 2 and 90. They are all pairs, 3 pairs of corresponding angles. So because angle 6 is because these two lines, let's call this A and B. A and B are parallel, therefore the corresponding angles must be congruent. So angle 6 must be 60 degrees. And because in B, A and B are parallel, and angle 5 must be 135 degrees because that's a pair of corresponding angles, right? And same thing here, angle 2 would be 90 degrees because they're corresponding angles. And by corresponding angles postulate, if the lines are parallel, corresponding angles are congruent. So make sure you complete the checkpoint. Here's another theorem. This one says alternate interior angles theorem. And it's fairly similar to the previous one. Again, same condition. if two parallel lines are cut by a transversal, then the alternate interior, meaning 4 and 5 are alternate interior, 3 and 6 is another pair. So the alternate interior angles are congruent. So like we said, 3 and 6 would be a pair, 4 would be congruent to 5. Also, just as a side note, remember 3 and 4 together, the sum of angle 3 and angle 4 forms a supplementary angle. The sum of 5 and 6 forms a supplementary angle. Okay? And here's an example. We have to find the measure PQR. So PQR is this angle here. And because PQR and 35 degrees are alternate interior angle, and also because this line, oops, sorry, let me erase that. Line A and line B are parallel. Let's call the top line A and bottom line B. They parallel. The alternate interior angles must be congruent. So PQR must be 35 degrees. And this one, PQR is here. And for C, PQR is right there on the left side of the transversal. And all of them are, you can say, because line A and line B are parallel, line A and line B are parallel, the alternate interior angles must be congruent. In the case of B, it's 120 degrees, and for C is 70 degrees. Here's a third theorem. Now, remember the first one says if two lines are parallel, the corresponding angles are congruent. Second one said same condition. If two lines are parallel, the alternate interior angles are congruent. This one is the same thing, except that now we're talking about alternate exterior, and these angles are also congruent. And so if line J and K are parallel, then line 1 and line 8 are a pair of alternate exterior. Line 2 and line 7 are a pair of alternate exterior. And let's look at an example of how to use alternate exterior angles. Excuse me. So here it says, find the measure of angle 1 and angle 2. And this is the situation where, like I mentioned, that the transversal is right here. This is the transversal, and my line A is there, and line B is here. If it's helpful, usually I like to see the graph looking something like this, right? So this would be my A, and this would be my B, and my 1 would be here, my 2 would be here. Actually, I'm sorry, I drew this backward a little bit. If I turn the paper sideways, you will see that the angle looks something like this. This is 1, this is 2, and this is 75 right here. So this is A, this is B, and this is my transversal here. Now, notice that what's given is 75 degrees right here. And because line A and line B are parallel, I should add these little arrows here. And now I know that alternate exterior must be congruent. So I can write that my measure of angle 2 would be 75 degrees. And that's because they're alternate exterior angles. Now, angle 1 and angle 2, if you add them together, they're supplemental angles. So supplementary angles. So they add up to 180 degrees. Now, if I substitute angle 2, measure of angle 2 with 75 degrees, and then keep the 180, so That's what I did there. I should have my angle 1 to be 105 degrees because I'm subtracting 75 degrees from both sides of that equation. My final answer is angle 1 is 105, angle 2 is 75. And as a way to verify my answers, I add the two together. I should have 180, which forms a straight line. So that looks right. Here is our last one, and this is a little tricky. Remember, the previous three sets says if two lines are parallel, the corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent as well. This one talks about same side interior angles, and in this case, they're not congruent. Rather, they are supplementary, meaning they add up to 180 degrees, right? So again, same side interior angles are supplementary. So angle 3 and angle 5 would be one pair, and angle 4 and 6 will be another pair of same side interior angles. So they each add up to 180 degrees. Let's look at this example here. Find measures of same side interior angles. Let me see if I can move the page upward. Let me move it up a little. Here we go. I have two angles there, and they happen to be same side interior angles. I also have two lines that are parallel as evidenced by these two arrows. Therefore, I know my the same side interior angles add up to 180 degrees because they're supplementary angles. And if I subtract 80 from both sides of the equation, I end up with 100 degrees. And for the same reason, I have a pair of same side interior angles. I have parallel lines. So when I have two lines that are parallel to each other and a transversal, the same side interior angles are supplementary angles, and they add up to 180. If I subtract 130 on both sides, I have my final answer for angle 6 measure is 50 degrees. Last example. This one is exactly the same using everything we've learned just now, but it has a little bit of algebra in it. So it's asking us to find x. Now, in order to find x, I have to find that angle first. So in order to find the x, I have to find out what that blue angle, that angle where the blue dot is. And I don't know that. I don't know what that is, but I do know that these two lines are parallel. If these two lines are parallel, that means my transversal is this almost horizontal line there. And therefore, I also know that I have my corresponding angles at 125. And by corresponding angle postulate, I know that they must be congruent. So that's how I draw the conclusion that x plus 15, that angle, has to be at 125 degrees because they're corresponding angles. If I subtract 15 from both sides, I should have 110 degrees. That's because I subtracted 15 from both sides to simplify it. Okay, so that's some simple algebra in there, but the important thing is to recognize that these two are corresponding angles. So please finish the checkpoint, and I will see you in class. Bye, guys.